Okay. E. Okay guys, happy afternoon. I think started or no? Started? Okay guys, happy afternoon. Okay, lights, camera, action. Yeah, I have to look enlightened. Okay. So happy afternoon. Okay. So I think right now record is being created, both the record and the record. Like not in case, with God's grace and all of your wishes, tomorrow when I become breakout YouTube professor, okay, I will have all of you to thank, and I'll be very grateful for the first video that got recorded. Okay. So thank you for coming. And guys, very small, simple, humble request is there. Please don't make a meme out of this, yaar.
This video will stay with you. If you don't invest.
Of course it will. What is the? It'll come to you. Please don't make a meme and circulate among students. Okay. Okay. What? This. It's getting no. Okay. So. What were we doing? Phase equilibrium, right? See, how do you want me to? Okay. So, do you want me to directly jump into the syllabus, or do you want me to give brief? No, because I am telling you it's very difficult to understand from the syllabus point of view. You need to go back to your 4th semester and understand why things are happening the way it is happening. Okay. So, we'll take some time. Okay, and go through the basics. Fine. So, pehli, phase, now under phase equilibrium, what we will do? Phase diagram will give you hidden information about how the phase transitions are happening, what temperature, what pressure, and everything like that. Okay. So this phase diagrams depends upon the number of components. Okay. If your component is 1, okay, it is something else. If your component is 2, something else. If its component is 3, it's something. So your syllabus starts from here. Okay. Which means you should have already studied this much, and this was already there in your 4th semester. Okay. So we'll go back to this single component phase diagram. Single component. Tell me something as some example, H2O. Okay, so under single component, there are 3 things that you should have studied in your 4th semester: H2, carbon dioxide, sulfur system. Okay, so now how will the slopes look like for a single component system? How will the slopes look like? See, they'll have different. Suppose this is solid, liquid, and vapors. Okay, why are the slopes like this? What is the reason? Based on the boiling points and melting points. So what is equal along these curves? No, what should be equal at this point? This is pressure and this is temperature. At this point, what should be equal? No. Of course, chemical potential, Gibbs free energy, molar Gibbs free energy should be same, right? So if I tell so what is dG given by? What is G given by? From your Maxwell equations. is equal to V dP minus S dt, right? Now what will your d mu, what is equal? Gibbs free energy or molar Gibbs free energy? So what is molar Gibbs free energy? d mu dP minus S molar dt, right? Right. So this should be same for both alpha phase and beta phase. So which means your V for d mu alpha is equal to d mu beta, okay, for phases alpha and beta. So now Vm alpha dP minus Sm alpha dt, it should be equal to Vm beta dP minus Sm beta dP dt. Okay, so can we take here Vm beta minus Vm alpha, okay, into dP is equal to Sm beta minus Sm alpha dt. Fine. See, from going from alpha to beta phase, okay, going from alpha to beta phase, if I take dP by dt, okay, dP by dt, so what will this be? Delta S by delta V, right? The transition, whatever is happening. Okay, so this is called as what equation? Clapeyron equation. You have studied two things: Clapeyron equation, Clausius-Clapeyron equation. So this is Clapeyron equation, right? No, if you are, there will come up time when I'll tell you to, I'll dictate, so you take during that time. Okay. So पहली solid और liquid boundaries. How are the curves given by solid and liquid? For this, see, what are you trying to plot? You are trying to plot pressure versus temperature. Who thinks? Okay, these curves will be given, dictated by the slopes. What is the slope? dP by dt, right? Now from solid to liquid, you tell me what is the volume change? Huh? Volume will increase. कितना increase होगा? कितना increase होगा? Okay, now compare with the volume increase from solid to gas. Compare and tell me, for solid to liquid what will happen?
Solid to gas will be more.
Solid to gas will be very high. Compared to that, relatively for solid to liquid it will be very less. Yes or no? So solid to liquid it will be lesser. So which means this dP by dt, okay, will be less. What will happen to the entropy from solid to liquid? Increase, and comparatively large increase, right? Okay. So large increase. What will give large by less? Smaller one? Huh? Large minus less. This increase was less, no. Large minus less will give what? Slope will be steeper slopes, right? So that is why for a liquid and solid, you will get a steeper slope. Now quickly tell me for liquid and vapor, calculate and tell me for liquid and vapor what kind of steeperness. Okay, steeperness will be less. Guys, should be careful, it's getting recorded. Okay. Okay, liquid vapor boundary. Liquid vapor boundary, what will happen? See, what will happen to the liquid to vapor? This will increase. Okay, this will also increase, right? But not as steeper as solid liquid. So therefore it will not be like this, it will be thoda like this, sleepy. Okay, so liquid vapor. Now tell me for what all we finish? Solid liquid, liquid vapor. Solid vapor का क्या होगा? Solid vapor का क्या हालत होगा? Very see, what will happen is that will not be the steepest. Why? Because see, delta volume will also increase enormously and delta S also will increase enormously. So which means it will be very similar to liquid vapor boundary.
Delta V is so much more different between solid vapor as compared to liquid vapor.
Delta
Delta V is way too much in solid vapor as compared to liquid vapor.
really? How? See, solid is here, okay, and liquid will what? Occupy little bit more than solid only. That relativity is less, right? But gas is constant, that final volume it occupies, gas is constant. So I agree that solid to vapor is increased little bit, but not very much. Okay, but the entropy is going to be same. Fine. Now what it will depend on is enthalpy, because delta S is equal to what? Right. So usually what will happen? Delta H sublimation is greater than delta S vaporization. Right. So what will happen to the curve? It will be steeper compared to liquid vapor, because this is higher. Fine. So what will happen? Delta S is equal to, so fine. So this is the whole, that is why the curves will be like that. So now you understood, right, how to find out the nature of the curves, the steepness and slopes.
But if you see that phase diagram is something like this, right?
Yeah. That is because they will be calculated at small this one, and then pieced together. It is not you cannot see delta, this delta you will not calculate for the entire range of this one. So it's like this, you will do that at the instantaneous point. So you and then piece it together. That is how you get that. Tell me.
To combine these three graphs, you will not get any shape close to that phase diagram.
You will not get any
shape which was close to the phase diagram you did first by column.
So essentially I have just pictured I have zoomed in and brought out like this. Okay, now how it is going to be, all are same only. Matlab, see here. So now what will your this one be? Solid, liquid. Okay, now liquid, vapor, steeper, and then little bit steeper, solid, gas. See, you will combine all these three. Got it? Fine. So shall I हाँ वाटर का आप बताओ फर्स्ट कार्बन डाइऑक्साइड का हम करेंगे. टेल मी फॉर कार्बन डाइऑक्साइड व्हाट विल हैपन. What will happen to the carbon dioxide?
The gaseous area under the gaseous curve will be more.
Area under the?
Gaseous curve will be more.
See, it will be something very similar to like this. Okay, very very similar. But just that, this what is this point called as? Triple point. What are these called as? Huh. Vaporization curve or you know what is this? Sublimation curve. Like what are that respective curves, right? हाँ कार्बन डाइऑक्साइड के लिए what will happen is I'll just essential features में बता देता हूँ उतना ही. So what will happen is this for is well above our room atmosphere, 5.1 atmosphere, है ना? Which means you cannot. What is our this one 1 atmosphere pressure, which means at this pressure there is no point how much you play with the variables pressure and temperature. Okay, you increase the pressure, you decrease the temperature, kuch bhi karo, you will never get a liquid, right? So that is why it is called dry ice, at this point, because this solid it will transition to liquid without entering into it will be solid will transition into gas without these things. We'll edit, okay, later. Solid will transition into gas without liquid, okay, that is why it's called dry ice. Fine. Water ke liye how is it different from carbon dioxide? For water, carbon dioxide is sublimation, but in water there is not sublimation. Come again. When carbon dioxide is going from direct solid to gas, but for water it has to go from solid to liquid, then solid to vapor. Fine, that is okay. Point considered. Now you tell me the nature of the curves. Nature of the curves क्या होगा? Will it be like this? Obviously, that is why I am asking. So tell me. Think no, थोड़ा दिमाग यूज करो, थोड़ा यूज करो. सिंपल का एक फंडा 8th क्लास. Yes, really, that is the answer. See, for everything, what will happen from liquid to solid? क्या होगा? No, size, volume decreases, right? For water, what happens? It increases. So how will it have a bearing on this?
No, I got it. I can't picture it on the graph. That's the problem.
That is the whole thing. See here. dP by dt will be what? Delta S by delta V.
So
It will be?
delta V should be
Delta V will be more than that.
No, liquid to solid. Liquid to solid. What happens?
minus is there for delta V.
Sorry. Here, sir. Solid to liquid. However, both of these. Okay. What will happen to the volume?
Can we take a negative value?
Huh?
Is negative value?
Yes. Delta V is going to be negative, which means slope it will not be like this. Instead, slope will be that same steepness only will be there. Okay. But slope will be like this. That is why that's the difference between CO2 and H2O.
Can you show how by solidifying the volume is increasing in this?
How?
How by solidifying the volume is increasing in this graph? How do we see that?
How do we see that? Okay. First, इस लाइन का स्लोप क्या है? This solid liquid is Positive or negative, you tell me. Negative. Okay. So which means delta S by this slope is negative. Do I show that volume is delta S by delta V? How do I show that volume is increasing through this graph? dP by dt is going to be negative. Okay, volume is increasing as you move from. Hey, can I do, see here, delta so from diagrammatically what I can tell you that it is negative value, yes, no. So what will be your delta VB, delta S divided by negative value, and what is your delta value? It is V final minus V initial, which is V liquid minus V solid. Okay, V liquid minus V solid, what is it? It started with solid and it went into liquid. So what is happening? Size, volume decreases. And that is essentially what is happening here. Delta S divided by minus T, minus. Got it? Huh? Got it, no? Huh. So sulfur का क्या है? Sulfur, what is speciality in sulfur? Yes, there are two solid phases, rhomboclinic and monoclinic, right? So its phase diagram will be how is it here? Okay, so this is rhombic sulfur, SR. Okay, this is monoclinic sulfur, this is vapor sulfur. Okay, and this is sulfur liquid. Okay, and there, huh? Yes, it has 3 triple points.
Actually, sir, rhombic and monoclinic, they have what of sulfur allotropes?
What?
What are their sulfur?
Two different crystalline forms of sulfur, just like how carbon is graphite and diamond.
So if
It is allotropes of sulfur only.
if it do a phase diagram of carbon, it will include all that as well.
Yes, you see, it will be very complicated. Even water also, even any of this one will be very complicated. It's not. This is the simple diagram for examination purpose and marks, right? तो अभी क्या होगा? So there are, okay, there is also something called as metastable state.
The solid cannot be liquid, sulfur cannot be solid state.
दो है ना, ये दो. See, SR and SM, rhombic. See, there are two crystalline forms, which means lattice arrangement different होगा, rhombic और monoclinic में. So दोनों ही, it is solid, liquid or vapor. Okay, so 3 triple points, fine. And what is in this, wherever there is an area, how it is bivariant, we tell. Bivariant means if you change both the things here, you can see from this point to this point, you can change both pressure and temperature independently, yet you will still remain in the same phase. Okay, along this curve, what will happen is, if you want to stay on this curve, you are there here, but you want to stay on this curve, what will happen is, Sunny, can you come front or something? No, you are actually blocking it. You're fine? Okay. The big head is. So from here to here, if you want to stay in the, see, you would just change the temperature. Okay, you cannot just change the temperature and stay on this curve. You also have to change the pressure. So it is monovariant. Okay, and triple points are invariant or non-variant. Matlab, you cannot. There is one triple point which you cannot change its value. Fine. Okay. So, one very important thing with this rhombic sulfur and monoclinic, this sulfur ka phase diagram is that, see, SR and SM, this transition is a slow step. It is a slow step, okay, because atoms are getting rearranged basically. Now what will happen is, if you increase suddenly the pressure and temperature, okay, and do not give it the time for this to transition, what will happen is, this will not, rhombic will not get into sulfur, it will directly go off like this. It will slip. This, okay. See, rhombic SR and SM transition is a slow step, okay. Time interval with respect to time interval, okay. But if you increase the temperature and pressure suddenly, okay, without giving it the time it requires for its transition, what will happen is, this SR will will not get converted into SM, but it will extend to this point. Means it will not get converted to.
So even it's going into that,
It's not getting. That is because you have not given the time that. So if you have not given the time, how will it get converted?
does that mean that point gets pulled there?
Point is,
That point is no longer time gets pulled there.
each point is pulled here. You are continuing to stay in this. Okay. And similarly, this curve, if you do it very quickly, you'll all get like this. If you do it fast. So for example, here. So essentially, you'll end up meeting at a point which is called as metastable equilibrium. Okay. Means not true equilibrium. If you do anything gadbad kiya, then you will get that point. That is a characteristic feature of sulfur diagram. Fine. Okay. So that was all about your one component system. Two component systems.
It's not necessary SM will be in the center.
It is.
This is not necessary.
What?
The position of SR and SM are given. The SM is in the middle. That's not necessary. It can be like SR can be.
No. It is like this. Rhombic sulfur is here, and no. What he's asking is SM here and SR being here, flipping. No, that is not going to happen. That has been studied and found out that this is how it is going to be. Okay, you cannot change because that depends on the pressure and temperature, the arrangement of lattice, right? Fine, that is experimentally found. We need not bother about it. Two component system, why is it important? किधर हम application two component system का application देखते हैं? Solutions, okay. Then where else?
Chemical reactions.
Then where else? Chemical reactions? No, these are transitions that are happening, not reactions. These are just phase transitions that are happening. Which industry heavily depends on two component system? Heat. Hint, it's a chemical engineering branch, starts with M. Mechanical. Nine. Medicinal. Nine.
Metallurgical?
Yes. Metallurgy, entire metallurgy depends on two component system. What do you do in metallurgy? क्या करोगे आप? हाँ? Since I cannot bend in front of camera, I'll pick up a new topic. हाँ, metallurgy में क्या होता है? See, usually metals are present as ores, so which means if you want to separate one from this, you have to play with the variables. That is what we do. Okay, so we'll quickly go through two component system and then jump into three component system. Okay. What is happening? It is recording, no? Please don't tell me to stop recording, यार. मेरे साथ बकचोदी मत करो यार. See, देखो टू कंपोनेंट सिस्टम में पहले व्हाट डू वी डू? फर्स्ट, इफ इट इज इमिसिबल, ओके, partially miscible, and miscible at all proportions. Right? This miscible at all proportions को हम फिर दो तरीके से बांट देते हैं. Here systems in which two components do not react, okay, but form something called as eutectic. Fine. Either it forms a stable compound, okay, and this is again divided into two things. First, if this stable compound has congruent melting point, okay, and one this if it has incongruent melting point. What does it?
If it is a stable compound, how does it have an incongruent melting? Like, is it possible half of it to melt first and then another half will melt?
So what is incongruent melting point?
Is what I'm asking you.
See, I'll come to this. Okay, so shall I? So we'll just study simple eutectic system type A, that okay. Okay, the general phase diagrams for these simple eutectic systems usually will look like हाँ, तो पहले नंबर ऑफ डिग्रीज ऑफ फ्रीडम क्या होगा टू कंपोनेंट सिस्टम में? कैलकुलेट एंड टेल मी क्विकली. How do we? So you put, what is the minimum number of phases that can exist in equilibrium? How? One. Simple. If it is like this, I can continue to stay in this phase, right? For F is equal to, so what is the for minimum minimum phases in equilibrium? So what is F? F is equal to C minus P plus 2. It's a two component system. 2 minus 1 plus 2 is equal to 3 है ना? So which means you need 3 degrees of freedom. What are all there? 3 degrees of freedom basically, which means you need 3 3 variables.
Actually, so when you say degrees of freedom,
When?
is it vibrational, rotational, वैसा वाला, or is it pressure, temperature?
What?
When you say degrees of freedom, because today when I was teaching, we said pressure, temperature, we said vibrational, rotational.
No, that degrees of freedom is different. That degree of freedom का मतलब, what is that degree of freedom? That you have, two molecules, for example, 3 COO, okay. So what are all the different things that can happen here? पहले it can translation motion. Translation motion का क्या हुआ? Which means CO2 that is there here, it is all going around. Translation motion, okay. Rotation motion, okay. Fine. See, the whole problem is when we think that there are actually 2 bonds, 2 डंडे हैं. सच में डंडे नहीं है. That is the mistake we do. When you remove dandes, then you will only get that कि it is not. It is. What? I don't want to miss any fun.
It is not the physical data which is there, it is imaginary.
हाँ, it is. मुझे उस डांडिया का नेनप आ गया. I got reminded of that dandiya. I paid 80 rupees for that.
40 rupees.
2 I purchased for Dilip sir, and the thing is, one 5th semester student, no, he came to me, he told, sir, don't go there and purchase. He gave me the branches. He told,
Branch.
I'll start learning Oriya yaar. Okay, see what will happen is this, so this is rotational, okay, and vibrational, so all different, symmetric vibration, asymmetric vibration.
This is not the same as pressure, temperature,
No, these are different degrees of freedom. These degrees of freedom are different. Means what is degree of freedom ka? Degree of freedom ka what are the different things you can change or play with? What are minimum things that you can play with? That is all the degrees of freedom, right?
So does this come under F or not?
This will not come under F. Why will this come under? You are dealing here with what? At a molecular, at a that is the difference. That is the difference between statistical thermodynamics and classical. Okay. So this is the whole between that micro wala, when you go ensemble we call, no, micro ensemble. This is the whole thing. हाँ, अब बताओ. हाँ.
So like whatever questions we are asking, so we don't know the question, there is no answer. It's okay, continue.
I'll buy a very very complicated set. Okay. Beda, not required. Hey, can I at the end we will do that. Okay. Credits. Tell me what is one improvisation that we should do here? What is this improvisation that we have to do from one component system to two component system when we come? कितना एक फेज को बताने के लिए हमको मिनिमम 3 वेरिएबल्स तो चाहिए. What are the 3 variables? First, let me ask that. Pressure, temperature, and nah. What did we do? How did we derive the Gibbs, the most elegant derivation in entire of thermodynamics? उसमें क्या यूज किया हम? And before that, see, both are chemical potential we used for equilibrium state conditions, right? इससे पीछे क्या यूज किया था? And did we use something mole fractions? Yes, right. So one of the variables is composition, right? Pressure, temperature, and composition. क्या हम? What will it become? 3. If I put 3, what will it become? It is it will become 3-dimensional graph. So which means we are students. हम नहीं कर सकते 3 एग्जाम पे कैसे? How will you put on scale and then see if we are able to do that? No, a student can always argue that, sir, I have drawn that, it is not. It will be who knows, right? So that can so that is why the founders of thermodynamics knew the intelligent students will do like this. So what they did is we always hold temperature, pressure, and composition. Now we hold pressure constant. Yes, that is why it is not F is equal to C minus P plus 2. It is F dash is equal to C minus P plus 1. So this is called as reduced phase rule. Understood? तो इसमें क्या हुआ? 2 minus 1 plus 1, so 2. You need 2 degrees of freedom. So that is temperature and composition wala. So how do we plot temperature? So there is temperature here. Okay, which means देखो temperature is here and temperature is also same this side. Okay, what is varying between here and here is composition. Okay, so this is, suppose I take mole fraction A, B, So A is 100% here and B is 100% here. In between it's a mixture of A and B. Fine. So what are the features of this phase diagram? So this is how we go about understanding this phase diagram. Let A be the what? Melting point or freezing point of compound A, pure compound A. Just like how we did pure compound, pure gas के लिए partial pressure P star रहेगा. So let that be this. Take down. A is melting point. Compound A. B is what? I'll tell you what is C. Now tell me, if you remember that phase thing which I, so much is there here, yeah, so much is there here to discuss. See here, remember I had done something like this where I told this is PA star, this is B star, right? Total pressure P will be equal to P partial pressure plus partial pressure of B, right? So this is when XA is equal to 1, then XA is equal to 0, right now, So analogous to that, why is it that when we add B, what is happening from here to here, we are adding increasing quantities of B, है ना? तो इसका melting point suppose I tell 500 Kelvin, इसका melting point suppose I tell 1000 Kelvin. In actuality क्या होना चाहिए था? What is supposed to happen? If I increase, so it should go like this, na? You also think. What is this? Freezing point curve, freezing point, दोनों एक, है ना? I'm giving you a hint. Okay, it is here. सीधा साधा it should be like this. Just like how total pressure.
What does that line represent according to total melting point?
What does
that line represent?
No. See, along this line, okay, see, I'm telling you this. This is the freezing point curve along this as you increase. Freezing point curve. Right? So, freezing point, as you add more and more of B, your freezing point for this composition will come down. Will decrease, and again it will increase and reach there. So this is freezing curve. Okay, why is it like this? Why is it not like this? So freezing point, no, देखो freezing point 500 Kelvin है, and you are adding some of B whose freezing point is higher, so it should be mean, right? 100 plus 1000 plus 500, depending upon ratio कितना हुआ है, तो that should be it should be simple arithmetic, Did you get the question? Why is it not this and why is it this?
Because of the interaction between
A and B, yes, because of the interaction between them. What do we have? We have a phrase for that. I thought this. I thought this. I thought this.
ethanol plus water
Ethanol plus water is fully miscible under colligative properties.
relative volume of freezing point.
Next point.
Elevation of boiling point.
Next point. Yes. What will happen? Depression in freezing point.
Lowering of freezing point क्या होता है?
Huh?
I said lowering of freezing point.
Oh, really? I thought. Sorry, yaar. I thought lowering of vapor pressure, yaar. See, depression. See, in my mind, I'm stuck with that answer. No, it has to be depression in freezing point. Okay, so that is what is happening here. Fine. Okay. So that is the reason. Okay, very important insight. If anybody asks, you tell. इस इधर क्या फेज होगा? If this is the freezing point or melting point, is a freezing point. A तो melt है, which means fully liquid. Just that it is different. They are miscible. They are fully miscible, and it is just a liquid.
Where did gas go?
Gas, you go here, no? When as this you increase the temperature.
So we don't represent gas.
Where are you representing gas? Gas you can do gas. You can, but you just have to extrapolate the temperature thing we are dealing with, you know. First of all, see, इसका melting point ही कितना है? 1000 means दो. It will be even higher. Here, what will this be? Solid A plus B. Here it is going to be B plus. Why is it happening like this? Any insights? In the
Initial cases, see the solid A is in maximum.
maximum.
So whatever we are adding, that is taken.
That is the freezing point of the
That is a freezing point ka curve. This happens to be a freezing point ka curve, which means lesser than this, you know, solid A will freeze. It will freeze, right? And then why is it solution of B? B ka bhi.
We are adding the right? You are upset that.
Why?
Because
Here,
it's solid
the curve will get solid B. How can you expect to get solid B here? This is the freezing curve for solid B. Like,
Okay.
so only if it is under that curve.
Correct. But my, extrapolation is, देखो, if it is like this, see, this is solid B, this is liquid B जो होना चाहिए था. If I pull it like this, right? If I extrapolate it like this, here what will it be? See, solid will remain here, right? All solids B, right? So this side it has to be melt liquid of that. Above that has to be, if you just, right? That is exactly what is happening. Now what is happening at this point? So this point is called eutectic point.
Why are you writing solution instead of liquid?
Why am I writing solution instead of liquid B? One, because it is not pure B. Pure B तो नहीं है. It is, see, pure B is here. This is, and then you can always ask, sir, if solid has, freezed, then the remaining should be pure. So,
You asked that question yourself.
yeah, or else you would have asked me anyway. तो क्या हो रहा है भाई? Why is it called solution of B? See, we have a wrong understanding of what a solution is. Wait. We have a wrong understanding of what a solution is. Solutions can be what all? Is it just liquid and liquid? It can be gas and gas, solid and gas. So in that understanding, in that light, if we go,
Then in that understanding, it should be solution of AB, not solution of A and solution of B. Okay, this kind of
okay, you all are toying with me now. I'll get back in C2, okay?
C1 remains.
C, दूंगा. C1 का range, okay. So this is called eutectic point. Take down, the point C is the lowest temperature. The point C is the low. Hey, happy birthday, Sunny. I got, okay, now thoda bulb. Happy birthday, right? So happy birthday. No, usually, I बोला ना यार ट्यूबलाइट तो हूँ, तो it just now flashed me that wow, come on, why you? यार, I thought you'll appreciate me for wishing. Now you are you are like you're finding fault with the just because I wished you. Okay, point C is the lowest temperature at which liquid can exist in equilibrium. Point C is the lowest temperature at which liquid can exist in equilibrium with solids A and B. At which liquid can exist in equilibrium with the solids A and B. What the sphere? नीचे तो solid ही है. Yes, there is solid below this. At this point, what is the equilibrium? It is actually like a triple point wala thing. There is a solid A and solution B and solid eutectic solid here. This solid. There is a solid B and solution of A, which means at this point it is in equilibrium with.
So why can point be on the line of A and B? Why it is above it?
What? Why?
Point C.
Like this?
I'm asking why it is above? Why not in the line of B?
This. So which means what you are trying to tell me is that at this point which means at zero temperature, with the slight increase in temperature, you want solid to jump into a if the meaning of this is, what is this? This is liquid wala. No, see here. I'll clarify your doubt. What is this? What is this above this liquid? Above this is liquid. Above this is liquid. Right? Now when you do like this, fine. When you tell this, at 0 degree temperature, there is a solid here, eutectic. Now with a slight increase of the temperature, you are expecting it to become liquid. That is not. It takes the minimum temperature. That is why it is not. It is well above 0 degree Celsius. That's all. Simple. is solid. Fine. So that is why that is an equilibrium. मतलब their solids, liquid is in equilibrium with solids A and B at this point. Okay. Eutectic is from Greek word easy melting. Melting. Okay. Means it melts easily. Okay, we'll just see one 11th वाला concept मजा आ जाएगा. Of this eutectic. Okay. So, an example of an eutectic system is lead silver system. Okay, so ये इसका temperature है, ये तो composition. So this is 100% of lead. Okay, this is 100% of Okay, those who are teaching 12th class, 11th class, please answer. Kiss, what is, from which ore do we get silver and lead?
From
Which ore do we get silver and lead? There is something called argentiferous lead. Okay, argentiferous lead का इतना ही है कि that contains about 0.1% of silver. Okay, which means it will contain 99.9% of lead. So which one do you want? Do you want silver or do you want lead? Be clear with your goal. Okay, you want silver? No, he told lead.
It is 99%.
Of PB.
Why are we going for silver?
Why are we going for silver? Yes. No, instead you ask, no, 1 minute, wait. What you told?
That is precious.
No, instead you ask, how do I make that silver higher? That would be the correct question.
Why don't I just take a better ore? Why should I extract silver from one?
Because silver is available as argentiferous red. Now, you want silver to grow from your tree or what? No. What is available in nature, that only we should take, no? No, you asked the right question. You understood that, silver is less. So now you have to ask me the right question. How do I increase that percentage? कैसे मैं increase करूँ? That is the. देखो, what we do here is we have a certain composition. So something here, right? 0.1% का मतलब क्या हुआ? Somewhere very less. This side of the curve, right? Less of silver, more of lead. So we first, okay, let us discuss this is 327 degrees Celsius is the melting of lead. Okay, this 961 is the melting of pure silver. Has anybody worked in that goldsmith? Any relatives working in goldsmith dukan? Huh?
They have not worked to me.
Not?
You said has anyone worked somewhere? Somebody said we didn't.
Oh no, I'm asking any relatives of yours have worked. See, they found a very interesting statistic. Okay, the highest number of people doing well in metallurgy course in IITs were from families which were involved in goldsmith wala, because they understood the concepts. Just like they all did practicals in घर में देखा है, father in, so it's a family business. If father is doing, even uncle will also be involved. So that is that, integrating what is their. Why do medical students outperform? Why they are better at academics? They study everything. That is right. See, every medical college has a hospital.
Yes.
Right? So which means what they are studying, they are able to see have a closer look even while they are doing. See, that doesn't happen with engineering. Most of the engineering students will become auto drivers, because they'll use autos to. See, the purpose of DMS was meant for that. Demonstration school was meant for us so that we go and demonstrate the best techniques. We experiment on them. कुछ भी नहीं हो रहा है, and it's getting recorded. Please note this. So what we do? We increase the temperature well above 961 and right, and then what we do? We drop that. We cool it. Zig 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 zig. At this point, tell me what will crystallize out if I decrease further now? Lead will decrease out. We studied that, right? Now, as the lead is decreased, we scoop out lead. What will happen then if we scoop out lead?
Solution of Ag is remaining.
Solution?
Of Ag is remaining.
Solution will scoop out lead. See, all the lead will not be. That is why it is not. Now that answer is, that is why it's not. That solution still, there is a solution which is still silver and.
So you are saying some amount of lead will still be
there.
It will be liquid under the melting point, freezing point.
Yes. Now how is that? How do I explain that? Yeah. Now if all the if you crystallize, if all the lead solidifies here and we remove that solidifies, suddenly what should happen to the mole fraction of this one composition? It should shoot up. It should become pure Ag, right? That is not happening. Record हो रहा है ना भाई?